In this video, I'd like to introduce the thought process that I go through anytime I'm dealing with a sloped surface, as in the case with number 9. So number 9 is the first introduction of having these sloped surfaces, these angled surfaces, that don't fall on an X, Y, or Z axis. And as a result, we need to acknowledge a few things about dimensions that are given and also the construction of this 3D model. The first thing that I look at here is the overall size of this object. So I'm seeing 1, 2, 3, 4, 5, 6, 7 long, much like the others. I'm also going to check the height, and I can see this is 1.5 and 1.5 inches, so it's 3 inches tall. I can also see that the width is 1.5 and 2, so 3.5 wide and 3 tall. I can go about creating this shape right away, and I'm going to do that, and it takes 2 seconds to hop over, and 7 inches long, 3.5 inches wide, much like the earlier models, and that the overall height of this with a push-pull is 3 inches tall, 1.5 inches. But if I come back here and I start to look at the next phase next portion that I'd like to adjust, and whether the order really doesn't matter, but this portion of the process definitely matters. When we take a look at the dimensions given here, we almost never see reference dimensions that are coming off of a sloped surface. So to assume that this is 1/2 inch is not a good thing to do. We almost never reference this diagonal edge when we're giving dimensions. We will, however, reference the starting and end point for these diagonal surfaces. So across the top here, I can see that this is 3.5, and I know the full length of this object is 7. So at the midpoint of this object, I need to cut a diagonal slope across this surface. So I'm going to come in here, and I'm actually going to do that right away. I'm going to come over to my back edge. I'm going to come in 3.5. I'm going to find the green dot that was constructed by that line I just created. And I'm going to connect that point with the other point that I know, which is the 7 inches, the end of this object. Whether you push-pull at this point or you do it after you've already cut that front notch out, in either case there's going to be a little bit of a hang-up between the two tools. I'm going to start off this time by doing this portion first and getting rid of the slope first, and then come back to my original orientation. In either case, you're going to get a few tools hung up. Whether you cut this portion first or you cut this portion first, you're going to have to do a little bit of tweaking to get it just right. 1.5 inches by 2 across the back edge. So I'm going to come over here, and I'm going to come across 2 and find that green reference dot, and then come down 1.5, which is halfway down the height of my object. At this point, I can now push-pull as far as it'll let me go. Once that push-pull tool runs into a sloped surface, it will stop you. Probably the easiest way is to just connect this out to the sloped surface. Again, we don't know the specific dimensions, the length of this line. I can see that it's 1 3/4 right now, but it's not important. What we need to do is make sure that we're push-pulling and removing the material that needs to be removed. My eraser will clean up that surface, and I now have this intersection between some straight, flat surfaces that are working directly in the X, Y, and Z directions, and then I have this sloped surface that have now come together nice and clean. One thing that you'll notice about this, I did not soften the edge. There is no hitch. There's no line in the middle of this, and so the one test that I'll do is I'll click here and I'll click here, and if at any point the surface, the edge along this plane, this angled plane, comes off of my line, I know that you've done something. It's not straight. It's not a flat, smooth surface. Even if you've right-clicked and softened an edge, it means you don't have a single flat plane. So that's the first part, or that's how I go about acknowledging